Okay, so this is for worksheet 12.6, but it's actually for chapter 14 to kind of get started thinking three-dimensional here. So basically, our next two assignments is going to be dealing with three-dimensional. So therefore, we do the derivatives. You kind of have an idea of what you're finding maximums, minimums, and all that is in three-dimensional. All right. So let's go through some rules here in terms of what kind of graph would happen. So first thing in three-dimensional, if one variable is missing, okay, basically what you're going to get is like a sheet. So think of a paper, kind of bend it, twist it, things like this. And so basically, if you took a sheet of paper and let's say you bent it a certain way, you would get something like this. This would be your function if you had one. Now you also could, bend your sheet of paper and let's do another one right above it. Bend your paper that way. So anyway, it looks something like that. If one of the variables are missing. Okay. All right. So that was pretty easy. So basically, if you had just an x, y, but no z. Okay. Now I'm going to go back to 2D and build off this. So if you had, let's say, x squared over 9 plus y squared over 16 equals 1. So remember, this would be an ellipse. So if you graph this out, you'd go 4 on the y, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3 on x, and you'd have this. Remember, if you put a negative in, that cuts the graph. So basically, this would cut it, so it'd be around the x. So you'd have a graph like this. So remember what a negative does also. All right, so let's start with in 3D, just being able to draw what we call an elliptical cylinder. Okay, so now if you start off with what we just draw here, so let's say, and I'm going to put a dash line there because that's going to be the backside. Draw another one right above it. Let's put another one below it. Dash it like that. And therefore, oops, didn't hit my cylinder quite right there. Therefore, you'd have a cylinder like this. Now, what we'll be doing after this is actually try to draw a picture, and then what we do is do a little cheating here. I usually come in and draw in my x, y, and z axis later. Okay, and then usually on the negative ones, I usually use dashes. Like so. Otherwise, too, a lot of times this is x, y, z, but as numbers change or negatives change, sometimes you might say, well, let's change it, and this is going to be my y, this is going to be, let's say, my z, and this would be my x. So I did a little cheating. Instead of trying to draw it laying down, I draw it one way, and then I change my axis. So I just change these values instead of drawing it differently, because I'm not an artist, so I find ways to help out my handicap. Okay. Let's try something in a parabol. and then go three-dimensional. So let's say if you have y equals x squared. Okay. So if you draw on something like this out, that would be what be in 2D. Okay, in 3D, I usually draw this multiple ways, but basically draw a parabola. Oops. Let's start over here. Okay, draw another one right above it. And then if you could just connect the lines here. There it is. Then let me come back and I could draw another one in here. And use dashed lines for parts you won't see. Yeah, sometimes too I draw it this way. Like so. And then, like I said, then come back in. I can put my axis in. So let's say here's one axis. Here's another one. Here's another one. Okay, so basically what we have here, since this is a parabola, this is referred to as a parabolic cylinder. Things like that. All right. Okay. So let's go into, let's say, drawing something like this out. So let's say you have all squares and they are all positive. Okay, this is going to be referred to as an ellipsoid. Okay, so if I had, let's say, ax squared plus by squared plus cz squared equals, and we'll do d will always keep positive. So if it's not positive, then we'll multiply everything by negative and then graph it up accordingly to that. So basically, what this is going to look like is like a ball or an egg. So if you can draw a ball or an egg, you got it made. Unfortunately, I'm not one of those people, but here is my attempt of drawing an egg. So first off, since I know this is going to be like an ellipse, I take off with drawing an ellipse. And like I said, there's my back side that you can't see. Front side you can. Okay, so then draw the top part of my egg. Oh, don't do that to me. There's my bottom side of my egg. And there's my egg. So then once I have my egg drawn, or my ball, come in, put my axis in. And this is, depending on which one is which. So I can make, I just make this X, Y, and Z, or change it up according to what my numbers are. Okay. All right, so what's the next thing here? Since we're all positive and all squares, let's change this to one of them being negative. So let's say if we have ax squared plus by squared minus cz squared equals d. Okay. All right. So remember, what does a negative do? Well, remember, an ellipse that cuts it and fillets it open. So the same thing happens here. So according to now what my d happens, now again, if you have different negatives, we can always multiply by -1 to change my my combination here. So this is, no matter what, if I multiply by -1 and I got two of them here, and let's say d is greater than 0. So it's going to fillet my egg open. So therefore, I'm going to have, let me get rid of that. Like so. And basically my graph is actually inside here. So and then come back in, put my axis in. There's my one axis, x-axis, and so on. If, say, d equals 0. So basically it pinches this together. So think of it as just pushing this in. So you actually have like an x, and your graph still looks the same. It's just been pinched. Okay. So what happens when d is less than 0? Well, then you basically cut that piece. So then what you have is a bowl on top, one on the bottom, and you just have that. And again, after you're all done, come in. I should have done here. Here's my x. Here's my axis. Same thing here. Which one's x, y, and z? Well, that depends on which one's positive and which one's negative. Okay. All right. That's next here. All right. So I gave some examples in my notes with numbers, but again, the numbers doesn't matter. Okay, we're just doing sketches so you get an idea of when we do derivatives and we find maxes and mins of, this would be a max here, but it'd be a max of a plane. And then there's to be a min here, and there'll be a plane here, like so. So hopefully you can kind of visualize what might happen when you start doing derivatives of these. That, like this one here, you could get a max and a min of this particular graph. Okay, that's why you're just kind of doing a sketch, kind of visualize max, mins, terrace points, where it's increasing, things like that. Okay. All right, let's try another combination here. So let's get rid of a square here. Okay. So we're doing when two variables are squared, okay, and one not. Okay, so basically you would have something like, say, ax squared plus by squared. So this would be plus or minus z equal to some number d here. Okay, so basically this creates, depending on the z, just one of these from the previous problem here. Let me just draw it up. So if z is less than 0, you get a problem like this. Like this, you only get one of them instead of two of them. So here is, I'll use a different color here, x, y, z axis, and this distance here depends on your d. So it's just a shift. So this is your vertical shift, side shift, whatever you want to do. So if z is less than 0, excuse me, we just did that one, z greater than 0, then you get upside down. Oops, and like so. And again, depending on what your d is, I mean, you could still have the axis could be up here, or it could be down below. could be different depending on what your d is. So basically, that's when you go down to only two are squared and one is not. Now, just to give you the name here, this is referred to as an elliptical parabola, or paraboloid, however you want to say that. Okay, but again, don't worry about the names. Okay, just be able to kind of sketch it out and realize, here you would only have, you're talking about maxes and mins. Here you don't have a plane, that would be a min. So you only have one, not two, and likewise the same thing. Here's your plane here, therefore that would be your one max only. Okay, where the other one you would have two of them. Okay. All right, just a couple more here. Next one, okay, so let's say we have a different combination of your negatives. Okay, so let's say we have, 2x squared minus 4y squared, where the other one was both positive, and then let's say minus z equals, and this is due 0. Again, this is just a shift. So, but I'm going to keep it simple here. So the big difference is this here. So what we get here is they refer to it as a hyperbolic paraboloid. Okay. The biggest word, obviously that you'll never remember, but this word you do want to remember. You're going to hear the word saddle. Okay, or later on a saddle point. Okay, so basically we're going to be drawing out a saddle. So how do you draw a saddle? All right, so first off, draw two parabolas, actually like a candy cane. Draw a candy cane, draw another candy cane. And now let's draw my parabola between the two candy canes. Now draw a parabola. So, and this would be, I should have did this piece here. Let me start over. And screwed up my first saddle. Okay, let's bring this down a little bit more. More of a candy cane. More of a candy cane. So there, like so. So here's where the saddle happens here. It comes down like this. So hopefully you can see this is like a saddle like on a horse. So the saddle point, and we're going to be finding these mathematically, is right here. That is referred to as the saddle point. Okay. So think of it like if you're hiking, you're coming down a ravine, and this would be where the lake would be down in here. So you're coming up off a mountain like that, or up here on top of a mountain looking down. It'd be that lowest point in there. Okay. All right. Now that's the last one here. So let's get rid of all the squares except for one. So if you have x squared plus y plus z equals 0. The last combination here. Okay. So let's think of it in terms of if x was 0, you would get something like y equals negative z, which would be a line. If y would be 0, you get z equals negative x squared, which would be some kind of parabola. If z would be 0, again, you get y equals negative x squared, which would be a parabola. So what's it going to look like? We'll put those three together. So parabola, parabola, and notice what you have here is like that trough, and here's your y equals this, and then again, I should put another parabola in the middle there. Once you have all that done, come back in, put your XY axis in. And who knows, this could be your X, this could be your Z, this could be your Y. It just depending on what combination you have here. Okay, again, this would be just a shift. So it just moves it up or down, left or right, whatever. But again, just in terms of what we're looking for. So when we get into derivatives, we're going to be looking for, this piece here, the min. So basically, this would be the lowest point, and therefore there's going to be a plane. I can draw it here. That will find that determines that minimum value. Now, likewise, the same thing if you draw it this way. There's a point, there's a line here. This line would be the line here, would create that maximum value. Or a plane that you could sit on top of it. So think of like putting a piece of cardboard on top of it, that max value. All right, so practice your drawings a little bit. There will be one like this on the test. But remember, I will probably allow you to use your bounded notebook with your own personal drawings in there. So normally I would have you memorize these, but since we're not in class practicing them every day, I'm going to allow you to use your notes. Okay, but the notes have to be bounded. Okay, so put this stuff in there and draw them out. Practice the saddle one so you can get a visual of what your saddle would look like when we do the derivatives. A lot of this is the terminology and wrapping your head around what the graph